Now, let's come back to the concept of stability. We've already figured out how to determine when a fluid is unstable to dry convection. But what about water vapor? Well, unfortunately, it's not possible to develop such a simple criterion as we did for dry air. But we can develop an approximate way of doing that. We can define something called the saturation entropy of the fluid. I'm going to have to do a lot more on this before this is ready for prime time. So I'm just going to skip over it now. In any case, we can define something called a moist adiabat, which is a line of constant saturation entropy, which is analogous to a surface of constant dry entropy in a dry fluid, except that the moist adiabatic lapse rate is not a constant. It itself is a function of temperature and pressure. But to a good approximation, the tropical atmosphere lies along a moist adiabat. So here, for example, is a moist adiabat in the tropics, and the solid line represents an average over several thousand soundings that were taken by weather balloons, showing that the temperature profile actually lies pretty close to one of these saturation adiabats until you get up into the stratosphere, which is just plain stable to convection.